I hope you're enjoying solving these 10 problems relating to linear systems. And we are really finding point of intersection using different methods. So here we'll again use graphical method to find the answer. Question number 6 is graph and find the point of intersection between the given lines. So the lines are y equals to minus 2 over 3x and x minus 3y equals to 6. So graph and get the solution and then watch my video for the suggestions. Here is my suggestion. The very first one is y equals to minus 2 over 3x. This is slope and intercept form, and at times I find students getting stuck because they don't have the starting point. They say, well, the y-intercept is missing. So from where can I start? That's a big question, right? This shows direct variation. What is the y-intercept here? It is 0. So if it is missing, you have to understand this equation actually is like this. Y equals to minus 2 over 3x plus 0, right? Since it was 0, there is no point writing it. Y-intercept is 0. So we'll start from 0, right? So specifically I've taken this example because I've seen sometimes that students get confused. We need to appreciate it. The y-intercept is the origin itself. And the way to look into this equation is it represents direct variation, right? With a negative slope. Now, if that is my y-intercept, the origin, then next point, how can I get? I can go 2 down and 3 right. So 1, 2 down and 3 right. 1, 2, 3. Get 1 point. Or let me see the equation in a different way. I can also see it like this. 2 over minus 3x. Do you see that? In that case, I can go 2 up and 3 left. So let's go 2 up and 3 left. 1, 2, 3. So we get the second point. And we already have the origin, which is our y-intercept. It also happens to be the x-intercept, right? Now, we can join these points and get the line. There you go. Remember, graphical solutions may not always give you accurate results. Sometimes we may get some fractions which are very difficult to read, correct? So that's fine. So that kind of error is acceptable when we are finding graphical solution. Now let's look into the second line, which is x minus 3y equals to 6. So if I have x minus 3y equals to 6, which method should I adopt to find or to graph this line? I guess it is intercepts. So let's find x-intercept and y-intercept, right? X-intercept is placing y equals to 0. So let's put y equals to 0. So if I put y equals to 0, what do I get? Y is 0, I get x equals to 6. Just hide this. Just hide it, right? So you get x equals to 6. So you get x equals to 6. So that is x-intercept. So do 1, 2, 3, 4, 5, 6. That is the x-intercept for us. Now for y-intercept, let's put x equals to 0. So if x equals to 0, minus 3y is 6. So y is 6 divided by minus 3. That is equal to minus 2. So that is this point. So we get x and y intercepts for us. Let me write the coordinates here. X is 6, that means y is 0. Here x is 0 and y is minus 2. So we'll join these 2 points. There you go. So just join them and see what result do you get. This looks like not a great point, or maybe whatever it is, we'll read from the graph and write it down, right? So that is the second line, which is x minus 3y equals to 6. Now if you try to read this point, it is right there, right? So x value is clear, which is 2, right? So we get x value of 2 and the y value is kind of in between 1 and 2. So that is what I was trying to say, that at times it becomes very difficult to read, right? So what we will do here is, now this point is kind of closer to 1, right? So it is not 1.5, but less than 1.5. So let me write 1 point, and of course negative, 1.3 for the time being, right? So that seems to be a very good approximation. But answer like 2, if you write 2 and minus 1.5, should be acceptable in graphical solution, correct? So that is how you can give your solution in such cases, correct? But the idea here is that at times graphical solution is not very accurate, but that inaccuracy is acceptable. I would like you to solve this problem algebraically and find the real point of intersection, accurate one. Okay, thanks and all the best.